Okay, our today's topic is matrix. It might be a new topic for some students. So first we have to understand what is a matrix. A matrix is a rectangular array of numbers, symbol or expressions arranged in a row and columns. The individual items in matrix are called the elements or the entries of the matrix. So what do you understand by this? Means it's a rectangular array which have some rows, which have some columns. It's an arrangement of row and column in a rectangular array. And what are here? These all are the elements or entries of the matrix. What kind of elements these are? That can be a number, that can be a symbol or expressions or trigonometrical function, rational, irrational numbers. It can be a symbol, it can be an expression, everything. So element can be anything in the matrix, but generally we have to deal with numbers. Example of matrix can be, it is always denoted by a capital letter, that is A, 1, 2, 4, and we have -3, 0, -1 and 2, 1, 2. So it's a matrix. It's not necessary that it contain only all the positive numbers. Numbers can be negative also. It can be 0, negative, anything can be an element. Now we'll draw a matrix that has an order of m cross n, so it will be more clear to understand the concept of matrix. We have a matrix of size m cross n. What do you mean by do we mean by a size? Suppose we have a matrix capital A and the size is m cross n. M means number of rows and n means number of columns. So this is the size of a matrix. It is generally have, the element should be denoted by small letters A, I, J. I and J are the suffix which denote the location of a element. These are actually the locators. It will tell you the location of each and every element. For example, we have A11, A12, A13 up to A1n. What it represent? It represent this element is first row and first column. This element is first row and second column. This one is first row and third column, and up to the nth column, means first row and nth column. Then on the second we have A21, A22, A23 up to A2n. What does it represent? It represents the second row, and here columns are varying. Similarly, if we talk about the mth column, then we have A1, AM1, AM2 up to AMN. This is mth row and nth column. So this is the way how we construct a different kind of matrix. And here m cross n will be the size of the matrix. Means if we have a matrix like 2, 1, 3 and 2, 1, 4, it means we have 2 rows, 2 cross, and we have 3 columns, 2 cross 3. Then next we have a different types of matrices. We have several kind of matrices. So first we'll take, what do you understand by row matrix? It means we have a single row in this matrix. If we have a single row in the matrix, then it's called a row matrix. For example, we have A equals to 1, 3, 5, 7. A single row, and we have 1, 2, 3, 4 columns. 1 cross 4. So this is a row matrix. Then we have, similarly we have a column matrix also. What do you mean by column matrix? Column matrix means a single column. It contains a single column. Suppose we have another example for this. We have 3 and 6. a single column. So single column is called a column matrix. Then our third matrix is a square matrix. A square matrix means whenever the number of rows is equal to the number of column, then it's called a square matrix. Means m equals to n. This is number of row and this is number of column. So number of row is equal to number of column, then it's called a square matrix. We can take an example for square matrix. For example, 3, 6, 12, minus 9, 0, minus 3 and 6, 3, 6. So what is this? This is a square matrix because number of row is equal to the number of column. 3 cross 3. So it's called a square matrix. Then next one we have diagonal matrix. Diagonal matrix means every matrix has a diagonal. Suppose we have D1, 0, 0, it's look like this. So there might be a diagonal DN. So what is a diagonal? This line is a diagonal. So in diagonal matrix we have elements on diagonal only, and all other means the non-diagonal elements, all these are 0. Whenever we have such a situation where we have elements on the diagonal only and all other elements means non-diagonal elements are 0, then it's called a diagonal matrix. For example, if we denoted by A, then we have 3, 0, 0, 0, 2, 0 and 0, 0, 4. So this is a very fine example of a diagonal matrix. And one thing you should note that diagonal matrix itself is a square matrix. Next we have identity matrix. Identity matrix. Identity matrix means we have the elements on the diagonal, but all the elements are 1 and rest of the elements are 0. Means whatever we have on the diagonal should only 1, not other number, not other than 1. That means it's a unit identity matrix, or we can say a unit matrix. Unit means 1. So unit, what is a unit matrix? Unit matrix means we have the diagonal elements as 1 and other non-diagonal elements are 0. So this is a form of a identity matrix. We have only two kind of element. One is 0, another one is 1. So it's called a unit matrix or identity matrix. Then other matrix we have scalar matrix. In a scalar matrix, what we have the element on the diagonal and all these elements should be equal. The condition is there should be an elements on the diagonal, all those elements should be equal and rest of the element, that is non-diagonal elements, that should be 0. Then it's called a scalar matrix. We have the elements on the diagonal, it's a square matrix itself. Secondly, we have the elements on the diagonal, but all that elements should be 0 and other non-diagonal elements should be 0. What we have, the diagonal elements should be equal. Then other we have zero matrix. Zero matrix, or we can say it's a null matrix. As the name explains, that all the elements in this matrix is 0. All the elements in the matrix is 0, then it's called a zero matrix. Then another kind of situation occur when we say that two matrices are equal. One thing I would like to tell, that wherever matrices is written, that means a plural of matrix. So another we have equal matrices. Equal matrices means if we have two matrices, for example A, and we have element Aij, its order is m cross n, and we have another matrix that is B. We have all elements Bij, that is of the order again m cross n. Two matrices are said to be equal if their orders are same. If we say that two matrices are equal, then the first and the necessary condition is that the order of those two matrices should be equal. For example, if we say A we have 1, 2, 3 and 4, and B we have A, B, C and D, and we have the condition that these two matrices are equal, that means 1 is equal to A, that means value of A is 1, value of B will be 2, then C will be 3 and D will be 4. So we have these values. Whenever it is given in your question, in your example, that the two matrices are equal, that means their corresponding values in the matrices, their elements should be equal. We can get the value of variable from here. A equals to 1, B equals to 2, C equals to 3 and D equals to 4. So this is the benefit wherever it is given that these are the equal matrices. We can find out the value. In our today's lecture, we will cover three operations of matrices. Three operations of matrices. The number one is addition. Second one is the scalar multiplication. And third one is subtraction. We have other operations also, but in our today's lecture we'll cover these. So first we have the first operation, we have the addition of matrices. Addition means obviously we are adding two matrices, but there is a condition for adding two matrices. The condition is that their order should be same. Only those two matrices can be added to each other if they are of the same order. Suppose we have A matrix, its elements are Aij, m cross n order, and we have P, that is Bij with the same order. So the condition is fulfilled. So we can add this A plus B, and their order will be remain same, that will be m cross n. Suppose we have two matrices -1, 2 and 0, 1, and we have to add this matrix with another matrix which is of the same order 1, 3, -1 and 2. We want to add -1 plus 1. This is the first element of the first row. Then second will be 2 will be added with 3. Then we have here 0, -1, and we have 1 plus 2. So you can easily see that only the order should be same if you want to add the matrix. So this is the way how we can add two matrices. Each element will be added which is of the same location. This element is A11 and for this matrix this element is also B11. The location is same, so we will add these elements. -1 plus 1, then 2 with 3, 0 with -1 and 1 with 2. So the resultant matrix we have 0, -1, 5 and 3. So this is how we can add two matrices. Another example we can take, if we have a column matrix also, then we can also add it, but obviously the condition remain the same, that they should be of the same order. 1, -3, 2. If we add this matrix with another matrix, that is -1, 3, -1, 3 and 2. Here it is -2. So the resultant matrix will be 1 plus -1, that is 0, -3 plus 3, 0 and -2 plus 2, 0. And we named it as null matrix because all the elements are 0 of this matrix. If we want to add 1, -3, -2 with -1 and 3, obviously this cannot be added. The condition is because the order of the two matrices are not equal. So it will be clear up to now that only those two matrices can be added if they are of the same order. Now we have second operation, that is scalar multiplication. Scalar multiplication means we will multiply our matrix with a particular number. For example, we have a matrix A, all the elements are Aij, M cross N. This is the way how you can represent the matrix, and we multiply this matrix with a number. We will write it as C Aij M cross N, means this number is multiplied with each and every element of the matrix. This is called the scalar multiplication of a matrix.